In this video, we will understand the chemical properties of acids and bases. Now, the first is reaction of metal with acids and with base. Now, what you should know that the general reaction that acids react with metal to give salt and hydrogen gas. Well, it is true for base as well. That is, base also reacts with metals, or we can say metals react with base to give salt and hydrogen gas. But there is a difference that most of the acids reacts with most of the metals to give salt and hydrogen gas. This reaction, that is reaction of a metal with base, is rare. That means only few active metals react with some strong bases to give salt and hydrogen gas. Well, in case of an acid, all those acids which are above hydrogen in the activity series. So if you remember the activity series, that is potassium, sodium, magnesium, like calcium, these metals, like above the hydrogen, will react with acid to give hydrogen gas. But the metals which are below the activity series, that is say copper, gold, if I write in order, it should be mercury, copper, and then this is silver and gold. These metals do not react with acid to give salt and hydrogen gas. So the reaction with acid, it can be, you can take other examples of an acid and our metals. So the example which is taken here is zinc. Zinc metal reacts with hydrochloric acid to give zinc chloride and hydrogen gas. Other examples we can take here. Let's say, for example, if I take aluminum, if it reacts with, say, another acid, say sulfuric acid, it will give aluminum sulfate, Al2SO4, and hydrogen gas is released. But as I said, the reaction of a metal with base is rare. So we can remember few examples here. That is, zinc metal reacts with sodium hydroxide to give sodium aluminum zincate, sodium zincate, and hydrogen gas is released. There's one more example we can take from here. That is, aluminum also behaves similarly. It reacts with sodium hydroxide to give sodium aluminate, that is NaAlO2. This is sodium aluminate, and hydrogen gas is released. Now, hydrogen gas so released, as you know, it's a colorless and odorless gas, but can be tested by bringing a burning splinter or a candle near it. You know that this hydrogen gas will burn with pop sound. So the next property is reaction of metal carbonates or metal hydrogen carbonate. You should know that metal hydrogen carbonate, also known as metal bicarbonate, right? So whether it's metal carbonate or metal bicarbonate, acid reacts with both metal carbonates as well as with metal bicarbonate to give salt, carbon dioxide, and water. So the three product is formed. So any metal carbonates, if it reacts with acid, or any metal bicarbonate, if it reacts with acid, then it will give three products. These are salt, carbon dioxide, and water. Now we have taken examples here, that is hydrogen chloride, that is hydrochloric acid, when it reacts with sodium carbonate to give sodium chloride, carbon dioxide, and water. You know that this is a salt. Now similarly, the products remains the same even if we react with acid with metal bicarbonate. And we can test the presence of carbon dioxide. As you know, carbon dioxide is a colorless and odorless gas. So we can test it. Two ways it can be tested. Number one, it extinguishes fire, right? Carbon dioxide is a non-supporter of combustion, so it will extinguish the fire if it is brought in contact. And the other, it turns lime water milky. So you should know that lime water is what? Calcium hydroxide. So lime water, that is aqueous calcium hydroxide. When carbon dioxide gas is passed through it, it gives calcium hydrogen carbonate. Sorry, CaCO3, calcium carbonate, CaCO3. And this is actually a precipitate, right? And this is the reason we say that the milky color appears. So whenever carbon dioxide is passed to freshly prepared lime water, it gives calcium bicarbonate, and that's why it turns the lime water milky due to the formation of a precipitate called calcium carbonate. But if we continue to add more carbon dioxide, that when excess carbon dioxide is dissolved, then the carbon dioxide will react with this product, say that is CaCO3 plus H2O, to give a soluble product called calcium hydrogen carbonate. And this is aqueous. And that's why the milky color disappeared. So when excess carbon dioxide is passed through the lime water, milkiness of the lime water disappears due to the formation of a soluble product, that is soluble salt, which is calcium hydrogen carbonate. So once again, we can review the general reaction over here. Whenever a metal reacts with an acid, metal carbonates or metal bicarbonates react with an acid or with a acid, then what is product? Salt, carbon dioxide, and water. Well, for bases, you should know that bases do not react either with metal carbonates or metal bicarbonates. So no product is formed. In fact, we said no reaction takes place when bases reacts with metal carbonates or metal bicarbonates. In the next part, we are doing a reaction of an acid and bases with each other. So what you have been knowing since very early class, that acid reacts with base to give salt and water. And this is called neutralization reaction, where acid loses its acidic character and base also loses its basic character. That means we say it's a neutralization reaction. So we know that acid reacts with base to give salt and water. But things we have to remember in this chapter is that not all bases are completely neutral. Bases can be acidic or basic. So it depends upon which is strong. So if I say that if both acids and base are strong, like if I take a strong base and a strong acid, in that case, the salt will be neutral. Similarly, if you take a weak acid and a weak base, the salt will be neutral. But if I take a strong acid, if it reacts with a weak base, then the salt so produced will be acidic. That means this salt so formed will turn blue litmus red. Similarly, we can say that if a base is strong, like if I take a strong base and if it reacts with a weak acid, then the salt so formed will be basic in nature. This will be a basic salt. Now we can take few examples here. Let's say, for example, if I take taking the example of the first type, strong acid. Taking an example of a strong acid, let's say HCl is a strong acid, and hydrochloric acid reacts with a weak base. So if I take a base as a weak base, I can take NH4OH, then the salt so formed will be ammonium chloride, that is NH4Cl, and water will be produced. So we'll say that this ammonium chloride is acidic salt. That means it will turn the it will turn the blue litmus red as it is an acidic salt. Now, for taking an example of the next type, we can take weak, whenever a weak acid reacts with a strong base. So for weak acid, I can take acetic acid, CH3COOH, acetic acid. That's 7 to 8% of acetic acid is vinegar only. And we also say its chemical name as ethanoic acid. If I react with a strong base, I'll take again the strong base as sodium hydroxide. So the result will be sodium acetate, which is CH3COONA, plus water is released. So you should know that in this case, the salt so formed will not be completely neutral. It will be basic salt, as you can see that the base is strong and the acid is weak. So this salt will turn red litmus blue if it is aqueous when dissolved in water. Now let's take example of the fourth type, where a strong acid and a strong base is there. So I can take example of a strong base, same as sodium hydroxide, and a strong base I've taken, and I'm taking a strong acid, then the salt will be NaCl. We know that is a neutral salt and water is produced. So when I took a strong acid and a strong base, we got a neutral salt. This salt will neither turn the red litmus blue or blue litmus red. For the fourth kind, is when both of them are weak. So the weak acid, I can continue to take the same, that is CH3COOH. Other examples could be uh, carbonic acid as a weak acid. And a weak base, I take NH4OH. In this case, it could be difficult for you to remember. So I can take other examples, say, if I take a weak acid, that means I can take carbonic acid, HNO, HCO3. This is carbonic acid. And weak base, for the weak base, I'm taking magnesium hydroxide. It's a mild base, milk of magnesia, which is used as an antacid, this milk of magnesia. So the salt aware here will be neutral, that is MgCO3 will be a neutral salt. So as you can see here, the acid as well as base are weak here. So the salt so formed will be neutral salt, and water will be released, as in case of all four cases. Continuing with the chapter, now we can do reactions of a metallic oxides with acids. Now, first of all, you should know that metallic oxides are basic in nature. Like if I say sodium hydroxide, sodium oxide, Na2O, magnesium oxide, MgO, these are metallic oxides. And when these are dissolved in water, it is basic in nature. If soluble, we say it's an alkalis, otherwise bases only. So these metallic oxides are basic in nature. So if I say that this is basic in nature or say base, so clearly it will react with acid to give salt and water. That means metallic oxides, which is basic in nature, will react with acid to give salt and water. Similarly, non-metallic oxides, these are acidic in nature. Like if I take sulfur, when it reacts with oxygen, gives sulfur dioxide. And this sulfur dioxide, if it is dissolved in water, gives sulfurous acid, that is H2SO3. This is sulfurous acid. So we conclude that non-metallic oxides are acidic in nature. And if it is acidic in nature or as an acid, it will react with base to give, again, salt and water. So we can conclude that metallic oxides, if it reacts with acid, it will give salt and water. And if a non-metallic oxides react with base, it will also give salt and water. This is because non-metallic oxides are basic in nature. Sorry, acidic in nature, and metallic oxides are basic in nature. So now we can conclude whatever the reaction we have done. So reaction of an acid, as you know, acid reacts with base to give salt and water, or a base react with an acid to give salt and water. Now, we also know that metallic oxides are basic in nature. That's why an acid reacts with metallic oxides to give salt and water. We know that non-metallic oxides are basic in nature, so it will give salt and water. So we have these two, and these two. Now, further, as I said in the beginning, that the first reaction which when we did, we said that an acid reacts with metal to give salt and water, and a base also reacts with metal to give salt and hydrogen, not water. But there's a difference that most of the acids, those which are above hydrogen in the activity series, will react with metal to give salt and water. But the reaction with base and a metal is not very common. Only few specific active metals reacts with strong base to give salt and hydrogen gas. Now, in the next, or what the leftover part is common, that is whenever acid react either with metal carbonate or with metal bicarbonate to give the same product, that is salt, water, and carbon dioxide. Well, the reaction of base with metal carbonates or metal bicarbonate does not takes place. The reaction does not undergo. And we have also know that this carbon dioxide so released is a colorless and odorless gas. So We use a chemical test for confirming this gas as carbon dioxide, and that is when carbon dioxide gas is passed through freshly prepared lime water. Lime water is calcium hydroxide, CaOH whole twice, and this is AQ. It results to give a precipitate called in CaCO3, that is a precipitate. So what we should know here that this precipitate turns the lime water milky. But then if excess of carbon dioxide is passed through this calcium carbonate, then what is going to happen that the milky color will disappear as calcium carbonate will change into calcium bicarbonate, and this is a soluble, that is soluble in water. It's an aqueous, that's why the milky color disappears. Now we can discuss some MCQ questions based on what we have studied. Question here is a metallic oxide when dissolved in water. As I told you that metallic oxide, say for example, sodium oxide, when it dissolved in water, it will give sodium hydroxide, which is clearly it's a base. So metallic oxides are basic in nature. The next MCQ says a magnesium strip or a metal is dipped into a solution of dilute hydrochloric acid. So what we know that magnesium is a metal, and if it reacts with acid, and we have to take an acid as what? Containing dilute acid, any acid it is there, doesn't make difference. We know that a metal reacts with an acid to give salt, and what is produced? Hydrogen gas is produced. So we'll say that we need to identify the gas here. So clearly the colorless and the odorless gas in this case is hydrogen. In the next MCQ, we say, what is the nature of non-metallic oxides? Well, non-metallic oxides, say for example, carbon dioxide, if it is dissolved in water to give you carbonic acid, HCO3. So all non-metallic oxides are acidic in nature. So acidic oxide is what our answer is. In the next question, it says, which of the following statement is correct? It says, all metal carbonates react with acid to give salt, water, and carbon dioxide. It says, the second is, all metallic oxides react with water to give salt and acid. So this is completely wrong, as we know that metal oxides react with acid. Not all metallic oxides react with water to give salt. And definitely they cannot give acids, right? Acids not possible. So some metal reacts with acid to give salt and hydrogen gas. This is correct because metal reacts with acid. Almost all metals, except for the noble metals like gold, silver, and copper, they do not react, but otherwise they react to give salt and hydrogen gas. It says next is some non-metallic oxides. So we have to choose for not a correct statement. So otherwise we have already identified this is not a correct statement. Then we can continue that some non-metals react with water to form an acid. Yeah, non-metal oxides like sulfur dioxide, if it dissolves in water to give sulfurous acid, that is H2SO3, similarly carbon dioxide. And we have already done that metal carbonates or metal bicarbonates react with acid to give salt, water, and carbon dioxide. We can take an example, say calcium carbonate. When it reacts with acid, say HCl, it will give you three products. One is the salt, that is salt here is calcium carbonate, then water and carbon dioxide. So the incorrect statement is this one. In this MCQ, it says marble chips reacts with a solution, any of these solutions, to produce a gas which turns lime water milky. So if it is turning lime water milky, the gas so produced has to be an acid. And we know that marble chips are what? Calcium carbonate. So we know that metal carbonates or metal bicarbonates. So this is marble chips is nothing but calcium carbonate, that is a metal carbonate, and it reacts with a substance, right, to give one product is carbon dioxide. We know the general reaction that metal carbonate or metal bicarbonates react with an acid to give salt, water, and carbon dioxide. as we have come to know that it is turning the lime water milky, then it has to be the calcium hydroxide, that is lime water. But what we have to look for is an acid here. Clearly, sodium sulfate, potassium sulfate, these are salt, lithium sulfate are salt, and we are looking for an acid, so it has to be H2SO4, that is sulfuric acid. The question says, what happens when sodium hydroxides react with sulfuric acid? So we know that sodium hydroxide is a strong base. Sodium hydroxide is a strong base, NaOH, and if it reacts with sulfuric acid, which is again a strong acid, so therefore the salt has to be neutral, that is Na2SO4 plus water. So the general reaction is a base react with an acid to give salt and water. Well, the strength of a salt, whether it's an acidic, basic, or neutral, depends upon the acid and the base. As we can see here that both acid as well as base is strong, therefore the salt has to be neutral. So it's a neutral salt will be formed in this case. In the next question, it says that which gas is liberated when hydrochloric acid is added to a sample of sodium carbonate. So what we know here that sodium carbonate is a metal carbonate, right? And a metal carbonate when and HCl is what? An acid. So it's the acid when reacts with a metal carbonate. What we know that whenever an acid reacts with a metal carbonate or maybe metal hydrogen carbonate, what is produced? Carbon dioxide gas is produced. So carbon dioxide should be the correct answer in this case. Continuing with the next question, we are on the next question. It says sodium hydrogen carbonate, when added to acidic acid, evolves a gas. So sodium hydrogen carbonate is sodium bicarbonate, which is a metal bicarbonate. So, and acidic acid is clearly an acid. So what we know that an acid, when reacts with metal bicarbonate or metal carbonate to give a gas, that is carbon dioxide. Yeah, what we know that the carbon dioxide, number one, it turns lime water milky, right? At the same time, the other is it, it extinguishes a burning splinter. It's a non-supporter of combustion. At the same time, we also know that this gas is which is soluble in this gas, that is carbon dioxide, is soluble in sodium hydroxide. So we'll say that these three answers are correct.